Hey guys, I'm Julian, your Infra Automation guy, and today we're going to look at Nushell, my new go-to shell. We will explore it in theory and take a look at a few demos. Let's get started. Have you ever written a bash script and thought to yourself, there has to be an easier way to do this? Well, enter Nushell. Nushell is a cross-platform shell that's focused on typed data and Unix-style pipelines. It's written in Rust, and similar to bash, it passes data across commands using pipelines. However, instead of using simply strings, it uses complex data types. I like to think about Nushell as the Rust-based version of PowerShell. Next, we'll go into how Nushell is half shell and half programming language. Nushell is half shell. First off, it is a drop-in replacement for the shell you use today, whether that's bash, Z shell, the standard shell, or PowerShell. There are three characteristics making Nushell a shell. Those are environment management, command interpretation and execution, and scripting and automation. Let's take a look.
All right, this first demo is going to be to showcase how Nushell is half shell. One of the key components of a Unix shell is to be able to call binaries and call additional applications that are installed in your system. Oftentimes, these binaries will be in directories that are defined in path, so you can easily reference them using the alias and not their absolute path. I have 4 examples here on lines 2 through 5. I will showcase how any one of these can be called and interacted with on Nushell. We will showcase Terraform version. This command will print out the Terraform version and then grep out Terraform to showcase that, yes, indeed, I'm interacting with the Unix-based external commands on Nushell. Man is another example. I can call man. It will open the command manual for copy files. And this is just a binary on my Mac system. I can interact with it with arrow keys, press Q to quit. Now, additionally, Nushell has built-in commands. Some of these built-in commands actually are aliased and named the same as Unix-based commands. And the reason for that is because Nushell aims to provide a more enhanced experience over these Unix-based commands. It is designed to output data in a better, nicer format and to return data in a typed manner. The command that I want to showcase to you is ls. And we can run ls here. ls prints out a table, and when we get into the programming language demo, we will talk about the different data types and what a table actually is. You can see in my IDE, I have the Nushell extension installed. One of the tenets of Nushell is to provide a great developer experience. I can hover over any of these functions, and it will give me a description of what it is. Now, you notice the built-in commands are blue, the external commands are green. If I hover over them, they'll showcase that it's external. Highly recommend downloading the extension. It makes life amazing. It cleared here. So the next thing that shells should be able to accomplish is calling external scripts. And there's kind of 2 primary methods to do that. You can just call a script directly using its file and just call it on your shell, or you can source it. And when you source it, you actually get the environment variables and the data as if you're taking those commands and calling them directly on your current shell. So I will showcase that on line 15 and call just this hello world script. It prints out hello Nushell verse. If I pop open this script here, you can see I'm setting an environment variable. Now, let's talk about environment variables before I showcase the source command. So environment variables in Nushell are very similar to, let's say, PowerShell if you worked in PowerShell. And they're a bit different than bash. So if I type out env, you can see that all of my environment variables print as a record set. A record set is just a set of key value pairs, and they are all listed in alphabetical order. if I want to set a custom variable, I can do that by essentially adding a key to this record set. Source that there. And then I can print it out and subsequently, I can subsequently use this in further commands. Right on my value. Now, if I want to set these environment variables in external scripts, I'm going to need to source these external scripts. And I could do that there. And you can see, okay, I just sourced that external script. I have it open here. Now, can I check to see what the value of this is? And yes, indeed, it's hello Nushell. Lastly, I want to chat about the Nushell config file. So similar to a bash RC file or a zshell RC file, the config.nu file is commonly used to set environment variables, set aliases, configure Nushell custom settings, maybe load modules. It's essentially in place to allow developers to define how they want their shell to be configured when it starts up. Now, the default config directory containing the config.nu file is found using the key of this new variable. Just look at this new variable. It's just a record. It has some information about how new is configured. And I can pop it open using just like a call to code, which is just external binary. In this case, it's my editor. Or I can define this environment variable here and then pop open config new, running like that. That pops it open right in my VS Code window. Now, let's say I want to define hello Nushell demo time in here. I can do that. I have that pre-configured. I'll close here. And once I pop open a new Nushell, I can take a look at what the value of hello Nushell is. You can see there it is, demo time. It's set by default when I open the shell. That should give you a good overview of what Nushell is in terms of a shell. Next, we'll get into what Nushell is in terms of a programming language and all the awesome and amazing things you can do with data types and loops and control flow statements. All the things that make Nushell an amazing replacement to Bash. Stay tuned.
Well, we just saw how Nushell was half shell, but Nushell is also half programming language. Like Bash, PowerShell, or Shell, you can write Nushell scripts and run them within your command interpreter. Additionally, Nushell supports many aspects of a modern programming language. Conditionals, control flow statements, variables, both immutable and mutable, and more. In this next demo, we'll take a look at everything you can do with Nushell as a programming language. Let's take a look.
In this demo, we're going to showcase how Nushell is half programming language. Some awesome tenets of programming languages include typing, variables, control flow statements, and operators. Nushell has all of those. So let's start by talking about how in Nushell, everything is typed. And this is one of the most amazing parts of Nushell. When we talk about pipelining and moving data across commands, in Nushell, this is actually sending byte arrays that represent the data's type. This is different than how it works in Bash. Bash is just sending strings. Nushell can decipher, okay, what is a list? What is a record? What is a table? And it creates this amazing ability to work with data across different built-in commands in Nushell. So let's start first by checking out what are some basic types. Ints, floats are just numbers, booleans, strings, lists. Those are pretty self-explanatory, just a true-false statement. A string is a string of text, a list or an array or a slice, depending on what programming language you come from. A record and a table. Now, these are a little bit different than other languages. A record is like a Python dictionary or a map. Now, a table is, I like to think about it in PowerShell forms, but essentially it's a list of similarly defined objects. And this is, you can create this manually like I did here on line 9, where you define headings. And let's actually take a look at this. You could define headings and then the data types that match those headings, almost like a CSV file. Let's take a look at table. Or if you have, say, an API that returns a list of records, and each of those records has the same key value pairs, well, you can create tables, and each table is going to have similar headings, and then every record in the table will have data, and you can actually see that. They'll be indexed and you'll have data. So I like to think about it as a list of objects. It's just in Nushell we call it table because it is so widely used on the CLI. Now the describe command will actually showcase what type a certain variable is. Let's define this here. And then we can print what each of those data types are using the describe command and the built-in print command. So int, float, bool, string. This is very useful if you need to check a specific type of a variable. Maybe you're debugging something. Maybe you're writing a control flow statement that it only applies to a list of strings or a list of integers. You can use this describe command to get the data type. Now variables. We've danced around this, but we haven't explicitly set or talked about what different variable types are. So in Nushell there are two specific variable types. There are immutable and immutable variables. Immutable variables are defined using the let keyword. Immutable variables are defined using the mut or mute keyword. Immutable variables, the value cannot be changed after definition. It's almost like a constant in a different programming language, where a mutable is more of a traditional variable. Its value can be adjusted across Nushell and across the script later down the road. So, for example, I have the hello world set here as a mutable, or as an immutable variable. I can print that out, but I can't add to it. And say I want to reset my var is equal to test. This should give me, oops, this should give me an error. Yep. And it tells me to declare the variable with mute. Now, mute is a bit different. I can adjust my variable here as mute, and then say I want to set a static int here and add 8. But I can also take this variable and say I want to reset it to 7 without redeclaring it. Whoops. I can do that. Now let's chat about control flow statements. Control flow statements, there's two primary ones in Nushell, if, else if, and else, and a match. So a match is more like a switch case, to where you're switching based on a value and you have specific cases that should match that value. Whereas an if statement is a traditional if, using Nushell's default set of operators. Now Nushell's operators are very similar to most languages. Equals equals for equals, less than will be just this alligator mouth here, less than or equal to. I think the only exceptions are or and. I think those are gotchas, to where if I need to define an or and a conditional, I have to actually spell it out. The or conditional would be like so. I could say or my mute variable equals 42. Thank you, Copilot, for that suggestion there. Same thing for and. I would need to switch this out to and. In other languages, you may be used to writing to ampersands. That's not valid, and that should error out right there on your IDE extension. Now let's talk about loops. So in Nushell, there are differences between loops and expressions, and this is a very core concept of Nushell. Loops do not produce output. There's no guaranteed output from loops, whereas expressions guarantee output every single time they run. So in a traditional programming language, you may loop through a range and then fill an array based on that range. Say I wanted to define an array here, and it was going to be a mutable array, and it would, we'll just say that, equals a blank line. I can loop through and actually fill that array like so by setting the value of array equal to itself and appending the iterator. And so after we run this, this array will have 1 through 5 in it as values, as indexes 0 through 4. Now you can see when I run this for loop, there was no output printed to the CLI. This is different than an expression, whereas an expression, it is assumed that every iteration is going to produce an output. Now this is more of a collection-oriented function, because now we can create essentially a temporary data structure each time that you run this expression. And there's several different types of expressions, but the looping expression is defined as each. You can see that there on line 61. Now let me define what tech stack is here so I can show you what that looping expression looks like. You can see by simply referencing the iterator, we get a table, in this case a record set of data. Now let's talk about default iterators in these loops. On line 61, we define the iterator right here using 2 pipes. On line 67, we do not define the iterator, and therefore we use the default iterator variable, which is in. See, we capture the output of each expression here, send it to a text subset variable. We can take a look at what this text subset variable is. And there it is. It's the same list, Nushell and Go. Now let's take a look at some real implementations of what programming in Nushell can be used to do. So the example I want to showcase today is simply outputting some Kubernetes pod information. First up, I'm going to define a custom kubeconfig file for the demo here so we can connect to a cluster, and we'll clear this out. Now I have some pod namespaces and pod names here. I'm going to showcase how we can loop through this without using a table, and then we will look at how we can use this using a table, do this using a table. So first off, I have pod namespaces and pod names. Now the ordered lists here indicate how they match. Index 0 shows what namespace the pod name of index 0 belongs to, so on and so forth down the list. So I'll just do that. And we can see here on line 77, we're going to loop through pod names and actually enumerate the values. Enumerating the values allows us to get the item and the indice of the list. So we can use the indice to get the namespace that the pod correlates to. And actually, before we run the loop, let's just take a look at what pod names, what enumerating them looks like. So you can see this. This table is created. It has an item heading, you can call it, and an index heading. So if I were to then get 0, you can look at index and item straight out of that table. So that's exactly what we're doing in this loop. So let's take a let's actually run this here. We can see what happens. And you can see here I am now using a Nushell loop to run an external binary command, which we showcased in the first demo. And I can get a pod based on the item of the pod and the namespace the pod's in using the pod index there. You can see this prints out. My default is defined to print as a table, but we will see how this can be changed when we use a table to actually print out this information. So an easier way to do this versus using two lists and having to keep track of indices is to use a table which has a list of objects. So this is a fancier way to define the same set of data, where each item in this list, each object in this list, has the same key value pairs. And if I just write table here, take a look at what table creates. So, and we'll just get index just to showcase that. Additionally, each item in the table has the same set of key value pairs, which is what allows Nushell to print out a table in such a clean way. If you think about Golang and how you can define a struct in Golang, so type, and then create instances of that struct, that's essentially what's happening here under the hood in Nushell. And it's similar in different languages, where you define a type and then you create an implementation of that type. That's exactly what's happening here in real time on the CLI. So now in Nushell we can loop through this table, and we will define on line 84 a custom iterator for this loop. It'll be pod, and then each instance of each item in this table, 0, 1, and eventually 2, will have its own set of data, and it is able to correlate pod name and namespace all together. So then on line 85, I'm able to call kubectl to get the pod name, referencing the pod namespace, outputting it to YAML, and converting it from YAML will create a Nushell table. Since it is in each expression, I'm expected to return data. So this will actually all be captured under this report variable. And once I print out report, you can see is one large Nushell table of data showcasing my 3 pods, 1, 2, and 3, and all of the data associated with them. From here, we're able to slice and dice this data as we see fit. Let's look at the select command. Select commands are great when you're looking at data on the CLI. You're able to select specific columns of tables or headings of tables, and you can run this here. You can see I've just selected metadata and kind for each item in that table. And say I just wanted to select kind, I can get subsets of the data in the table. Additionally, I can save these reports back into YAML. So I can run this on line 92, and we can take a look at a pods report. This works with all kinds of different data types that Nushell supports. I can export this data out to an Excel spreadsheet, to a CSV file, to a JSON file. Take a look here. Lastly, I want to showcase the where command. So where allows us to create a conditional and look at each object or each item in the table and match whether the conditional matches that item, and then return a subset of items back to us. So in this case, I'm going to look through each pod that I pulled, and I'm going to look for the metadata labels that match helm.shell/chart. In this case, I'm only returning a single pod because only one of these pods was deployed via Helm. You can see the labels here. No other pods were returned. Once again, I can use that where command to create a report of just the pods that were deployed with Helm. This is very useful when you're dealing with large amounts of data. You can pull, slice, and dice data how I see fit. So this is just a sneak peek into what Nushell supports in terms of programming languages. This is how you would write very impactful Nushell scripts. I hope this fires you guys up and gets you excited about using Nushell. This is just a little taste and a sample. We could go on for a long time about all the neat aspects of Nushell.
Today we took a look at Nushell. I hope you all find it as valuable as I do. We'll make sure to include the installation guide in the description below. Comment, like, and subscribe, and I will see you all next time.